Good day. Today, we will be discussing an audio amplifier. So, amplifier is the generic term used to describe a circuit which produces an increased version of its input signal. However, not all amplifier circuits are the same, as they are classified according to their circuit configurations and mode of operations. There are many forms of electronic circuits classed as amplifiers, from operational amplifiers and small signal amplifiers up to large signal and power amplifiers. The classification of an amplifier depends upon the size of the signal, large or small, its physical configuration, and how it processes the input signal. That is, the relationship between input signal and current flowing in the load. So, in this video, we will be focusing in a Class AB amplifier. So, why is it important to know the class of the amplifier that we are going to make? When designing amplifier circuit, the class of operation of an amplifier is very important as it determines the amount of transistor biasing required for its operation as well as the maximum amplitude of the input signal. So here is the table for the comparison between the most common types of amplifier classifications. So a Class AB amplifier is a combination of Class A and Class B to achieve an amplifier with more efficiency than Class A but with lower distortion than Class B. This is achieved by biasing both transistors so they can conduct when the signal is close to zero. Now that we have an idea what an AB amplifier is, let's proceed with the making of our circuit by using a multisim.
First, we will put an input signal with 500 millivolts and 60 kHz. Since biasing using a resistor may cause a problem in temperature, we will be using a pair of normal forward biased diodes. The first transistor that will be used will act as a current source that sets up the required DC biasing current flowing from the diodes. Then, a pair of complementary NPN and PNP transistors is used. We also implemented input coupling capacitors and an output coupling capacitor. As the input signal drives the base of our first transistor, it acts as an amplifier stage driving the base of our NPN and PNP with the positive half of the input cycle driving NPN while our PNP is off, and the negative half cycle of the input cycle driving the PNP while the NPN is off. The implementation of Class AB amplifier is very similar to the standard Class B configurations, in that it uses two switching transistors as part of a complementary output stage. Now that we are done doing our circuit design, we will now put probes to compute our amplifier gains and an oscilloscope to compare the waveform of our input and output signals.
Now that we already have our circuit, we will now convert it into a printed circuit board.
Like with most electronic circuits, there are many different ways to design a power amplifiers. As many variations and modifications can be made to a basic amplifier output circuit. The job of a power amplifier is to deliver an appreciable level of output power to the connected load with a reasonable degree of efficiency. Based on the results we get from the simulation earlier, we have seen that Class AB amplifier configuration is more efficient than a Class A amplifier but is slightly less efficient than a Class B because of the small quiescent current needed to bias the transistors just above cutoff. However, the wrong use of biasing can crossover distortion spikes, producing a worse condition. With all the characteristics we've mentioned, we can say that Class AB amplifiers are one of the most preferred audio power amplifier designs due to their combination of reasonably good efficiency and high quality output, as they have a low crossover distortion and a high linearity. Nowadays, audio power amplifiers are economically noteworthy and essentially a commodity. Growing technology and high adaptation rate of these high-end products worldwide are dominating the market of power amplifier. Therefore, a Class B amplifier predominantly monopolized the trade of audio power amplifiers since it offers adequate compromise between linearity and efficiency, and they emulate the finest class amplifiers in sound quality.
We will now be computing the amplifier gain of our circuit. So we will be using these formulas.
For our voltage gain, 6.49 over 1.41 is 4.60. For our current gain, 405 milliampere over 180 microampere is 2,250. For our power gain, 4.60 times 2,250 is 10,350.
So that's the process of making a Class AB amplifier circuit. I hope that you learned something from me. Thank you for listening.